Hello everyone, this week our new video is going to focus on atom, isotopes and ions. Okay, you have to remember for atom it consists of 3 subatomic particles: electron, proton and neutron. So in this picture, you can see that it has shells at outside and things in the middle. So in the middle you must remember it contains only proton and neutron, known as the nucleus. While at the outside it contains shells with electrons inside. So you have to remember the electrons are the only one that will leave your atom, while proton and neutron, they are always stuck in the center. So in this table you need to learn that what is relative mass. A relative mass is a comparison. For example, I would say that 2 chairs equal to the mass of 1 table. 3 apples equals to the mass of 1 pineapple. Or maybe your friend, 1 friend equals to the mass of 3 elephants. Something like that. It's a comparison. It doesn't have a unit. So at here you have to remember electron has a relative mass of 1 over 1840. While proton and neutron is just 1 and 1. Which means you need 1840 electrons to equal to the mass of 1 proton or neutron. Okay, so you must remember this. The mass of electron is basically negligible. Okay, and the next one is your relative charge. You need to memorize electron. Each electron has a charge of -1, and a proton has a charge of +1. And neutron, as it is neutral, it has a 0 charge. Okay, so when we look at an atom, it always exists as this symbol. It has an atomic mass showing on it and the proton number. You must remember the atomic mass is always the bigger number because it is the total mass of this atom. While your Z, the proton number, shows the number of proton. We have to remember one thing. It shows the mass of proton and mass of atom. So if you use the mass of atom minus of the mass of the proton, you can get the neutron number. As what we saw in the table just now, the mass of electron is negligible. We only consider the mass of proton and neutron, which is in the center of the atom. Okay, so you have to take note of this equation. And then the next one is, you must always remember proton number and the electron number will be the same for a neutral atom. We will see in details later. Okay, the next one is cation and anion. You need to remember this term as well. Okay, a cation, it is a positively charged ion, which is formed after you lose electron. As for anion, it is a negatively charged ion which is formed after you gain electron. Okay, so you can see cation, this T, it looks like a positive, which means just remember cation is a positively charged ion. However, to make it easy, just remember electron is negatively charged, which means when you lose away negativity, you'll be more positive. Okay, just like this. So now you can see we have this example with Na and 23 and 11. So you must remember this Na means it is a sodium atom. 11, as we can see, is a smaller number. It is a proton number. So since Na is neutral, when I have 11 protons, I will have 11 electrons as well. And since 23 is a total mass, I should know that my neutron number is to use 23, the total number, minus of 11, and I will have 12 neutrons for this sodium atom. Okay, the next one here. We have this Na again, but this time it comes with a plus charge. Remember, 1 plus means it loses 1 electron. The proton number for Na plus cation, it is 11 because proton, remember, it never changes. As for the electron number, because it loses 1 electron, so I will use 11 minus 1 means I only have 10 electrons for this Na plus ion. As for the neutron number, my neutron number is simply 23 minus 11 and I will get 12 neutron numbers. And remember, the proton and neutron numbers, they never change. Okay, the next one is your magnesium, and this time comes with 2 plus, which means it is Mg2 plus cation ion. Again, proton number never changes, it's still 12. Electron number is because I loses 2 electrons, so I will use 12 minus of the 2 to get 10 electrons. As for neutron, it's the same method, 24 minus 12, I will get 12 neutrons. Next example here is a O2- oxide anion. Proton number is still 8. Okay, and since it gains 2 electrons, so the electron number here is going to be 8 plus 2 give you a 10. And lastly, neutron number, the same method, in 16 minus 8, you will get 8 neutrons. And again, proton and neutron number, they never change. Alright, so in this chapter, you also have to remember how to construct electronic configuration. You will see that it is mainly focusing on arranging your electrons. So what you have to do, the 4 steps. First, you need to identify the total electron numbers for this atom. And then as you can see in this picture, it contains 3 shells. The first shell, remember, it contains only 2 electrons. While the second and third shell, it can contain up to 8 electrons. So if there are more electrons, you'll put them in the 4th shell. Okay, this sulfur, as you can see here, it has 32 and 16, which means it has 16 protons and also 16 electrons since it is neutral. So 16 electrons. In the first shell, I will put 2 electrons and left with 14 electrons. So in the second shell, out of the 14, I will place 8 electrons in the second shell, and I'm left with 6 electrons. So these 6 electrons I'll put in the third shell, and this gives me an electronic configuration of 2.8.6. Okay, this is very crucial. You all must remember. Okay, I'll give you more example. Now we are using a S2- anion. So 2- means it gains 2 electrons. So I have 18 electrons now. So the first shell I'll put 2 electrons, second shell I'll put 8 electrons, and the remaining 8 electrons I'll put in the third shell to give me 2.8.8. So how do we decide what kind of numbers we want to put in each shell? You must remember the ideal scenario, we want to have the most outer shell to fill with maximum 8 electrons. Because these 8 electrons in the outer shell, we will call it the octet structure. It can give the ion stability. Okay, so always remember, for the second and third shell, we aim to have them with 8 electrons maximum, while the first shell is only capped at 2 electrons. Okay, so we can go into details with more example in our online lesson. Alright, now we are moving to a new thing in this chapter again, is known as the isotope. Okay, you must remember isotope has the same number of proton. As we know from just now, a proton number and electron number will be the same for a neutral compound. So you must remember, proton starts with a P and electrons with a E. So if you look at this term isotope, it has a P and E, which means the P is the proton, E is the electron, and also the element. You must memorize in exam, you must mention the word element. Okay, so isotope is the same element with same proton number but different neutron number. Right, there's no N in this isotope, this word, so neutron number is always changing. Just a method for you to remember. At here, I will give you 3 examples. So basically everything has isotopes. I'm using oxygen 16, 17, and 18. So this oxygen 16, it has 8 protons, 8 electrons, and also 8 neutrons, calculated when you use 16 minus 8. While oxygen 17, 8 protons, 8 electrons, and when you use 17 minus 8, you will get 9 neutrons. As for the last one, 8 protons, 8 electrons, and when you use 18 minus 8, the last oxygen isotope has 10 neutrons. So you should realize, for the all isotopes, their proton and electrons stay the same, but their neutrons are changing. Okay, so for isotopes, this part, you must memorize the example for each isotope and what they are used for. For medical, it's always isotope with big number. Agriculture, we will use mainly the phosphorus 32 because phosphorus is used for fertilizer. And carbon 14 is always for archaeological uses, which is to estimate the age of bones or fossils. The next one is power source, you use uranium 235, and industry, you will use sodium. Okay, so the last thing for isotope is very straightforward. For isotope, you must know how to identify atomic mass. So if you look at this picture here, Cl17, 35.5. 17 is a proton. But how come it has a mass of 35.5? Okay, because this 35.5 is the average mass. So let's show you how we can do the calculation. So in the atmosphere, we know that we have 25% of Cl37 and 75% of Cl35. So what we have to do now is we use 25% times the mass of Cl37, add up with 75% of Cl35, divide by the total composition, which is 25% plus 75%, and you should get 35.5 based on the calculation. So you must remember all of the mass that we see on our periodic table, they are all the average mass of each element. Okay everyone, we have come to the end of this video. To learn more and get tips to score A, you may join my online lessons, where I will share with you tricky questions asked in exam, and you can even get my free notes. See you soon, bye bye.